Getting there. Hang in there. Number 25. Sticking with the logarithms. Simplify to a single logarithm. All right, well, we're going to go one piece at a time. Notice we got a lot going on here. Here's law of 3 just lurking. And on these, you want to attack law 3 first. So I'm going to rewrite this. Log base 7, 2 cubed is 8c cubed plus log base 7, 3d. So what does this mean? It means multiply that stuff by that stuff. The 2 shall become 1. So this log and this log becomes 1 log. Then we multiply 24, keep it in alphabetical order, c cubed, because I went 3 times 8 times d, minus, now watch this, I'm going to bring that right here. Now, the more you see this, the more that translates into 36, the square root of 36, because that 1 goes here, that 2 is your index, and the more you're around math, the more it just clicks. And what's the square root of 36? 6. So that turns into 6. Now, if you got common bases, 2 logs, subtraction. Subtraction means division. The 2 shall become 1. I'll write my answer over here. So 7, first stuff goes in the numerator. Second stuff goes in the denominator. And as you can see, that will reduce. So log base 7, 24 goes into, or 6 goes into 24 4 times. So 4c cubed d. And there's that one. Okay, so now 26 has a little twist. And they're giving you some values. If log of base b x equals this, so what they're doing is they're really saying find this, manipulate this until you have this, and then replace that with 3.1. And then do the same thing with this. You have to create this and then replace it with 4.2. And the same thing here. So as you can see, we're just going to stick with our rules. We're going to ignore all of this at first and just kind of remember, they just want us to practice our rules. And this is a mol problem, so this is going to split into 2. And multiplication, that's what that is, means addition. And notice we've already got this, so we can replace it with 4.2. This we can put in the front, so it's really 2 times log base bx. Remember, we're going to replace that with 3.1. So this turns into 2 times 3.1, which is just 6.2, plus 4.2 from here, and that would just be 10.4. Just a creative a little different twist on stuff you've been working with. Same thing here, but now we've got the z involved because you can see the z. Now, what jumps out at you? Well, if we can clean this up, look at it a little differently. Z to the square root is the same thing as z to the 1/2 power. You know, I'm going to do that later. Now, I wasn't going down the wrong road. I just noticed something that I think might be a little bit easier. I could be wrong. But I'm going to use law 3 first and bring that in the front. So then I can attack this with just less stuff. So there's a 3 out there, so I essentially got rid of that, so I don't have to deal with that. Times, watch this now, log b, square root of z, I'm going to write that as z to the 1/2 power over y to the 5th. Now I'm really focusing in here. I'm not worried about the 3 because now division means subtraction, so this turns into 3 times log base b z to the 1/2 minus log base b y to the 5th. So again, I'm not worried about this, but I'm going to bring this in front of here. I'm not worried about this yet. So 3 times 1/2 times Now when this comes in front of this, I can go ahead and substitute it with 5.3 minus, and now when I bring that 5 in front of this, it's 5 times this, which I can substitute with 4.2. And now it's just a PEMDAS special. So I'm going to get my calculator out here, and here we go. 5.3 times 0.5, which is a half. So I get 2.65 minus 5 times 4.2. Oh yeah, 21. Could have done that. So, but now I'm going to go 21 minus 2.65. But I know this is a negative 18.35 times 3. And that would be a negative 55.05. All right, let's go on to this. Graphing logs. So, first of all, if we recall, x can't be negative, which means and x can't be 0, which means there's an asymptote right here, and we just need to know that. And also, if we're thinking about parent functions, this is y equals log of x, and if you remember, your basic log has a 10 and this is a 2, and we can get all freaked out about that, but essentially there's not a huge difference. So the parent function of this, if you recall, if I spin this around, it's 10 to the y power equals x. And if you recall, our locator point is 1, 0. Now what does that mean? It means x is 1 when y is 0. And if we plug that into this stuff, we'd get 10 to the 0 power is 1. We go, yeah, I guess that's true. So I'm just bringing this to your attention so that you can remember that is your locator point, and then your parent function looks a bit like this. So if that's a 10 and that's a 2, there's a little bit of a difference in here, but not much. This is the same, very much the same. Now what's that 4 going to do? Well, that's your a, so it's going to be a vertical stretch factor of 4, and so I guess, hold on, I didn't read the instructions perfectly. Okay, so lesson to you guys, read the instructions. So I just demonstrated how anybody can get kind of lost in their own world. This is telling us graph the following functions and label at least 2 points that have integer coordinates. That means we need to be a lot more precise about our thoughts. I just initially, out of habit, went to this, like, hey, if the base is 10, it's not much different than that, so let's just talk about this. And that's all true, but it's throwing us off this. So here's what we need to think about. We need to think about this as our parent function and not that. Now here's the good news. I said the point 1, 0 over here works, and that's your locator point. And let's talk about that one more time. If x is 0, if x is 1, y is 0. If we think about that, this is 2 to the y equals x. So let's rewrite it and think about it. So 2 to the 0 power is supposed to equal 1, and that's true. If we plug these values into this, which is the same thing as this. Now they want 2 points. So we found one of them, and they want another one. Well, if we just kind of think about this for a second and just think, well, let's let y be 1. And how would that change x? Well, that'd be 2 to the first equals x. And notice I'm plugging things in for y because that's easier to find x if I know what y is. That's just what I'm doing. So 2 to the first would equal 2. So if y is 1, x is 2. So there's another point, but here's the twist. That's for our parent function. You see this 4 here? We know that it's going to be, and remember, this parent function is very similar to this one, so I'm not going to rearrange this because I do know the locator point's the same, but here's the twist. If this is a point, 2, 1, for our parent function, and now there's a 4 in front of it, that's going to multiply our y value by 4. So 4 times this. So really, on this function, it's not 2, 1. We are going to take 1, 0. That doesn't change. But we're going to multiply the y value by 4, so we actually get 2, 4. So 2, and then 1, 2, 3, 4. So that is a definite change there because of that 4. Vertical stretch factor of 4. All right. Hopefully that didn't confuse you too much. Took a lot of time, though. All right. Well, let's stick with this guy. So once again, y equals, we better be consistent here. There's our parent function. So the good news is we know that if x is, if we know that our locator point is 1, 0, let's test it out, but let's go for it. We also know that our asymptote is here still. Oh, and I did forget domain range. We'll get back to that in a second. So 1, 0 is our locator point, and if we take a look at it, this is going to go like this and that. Now we are saying find 2 other points. Now this one will be a little easier. 2 other points for this. So what this does is it moves it left 1, so that means it moves everything left 1, and then down 3. So if we move that left 1, down 3, 1, 2, 3, now we know one of the 2 points is going to be 0, -3. So there's 1 additional point. And I'm going to draw this in. I'm going to try to be really careful because everything moves left 1, including the asymptote. And so now we've got this drawing here, and we got to really pay attention to this guy to find a second point for this, and then consider where it moves after we go left 1, down 3. So what I'm going to do, remember we twist this into an exponential and it helps our brains focus on it a little bit. I'm going to plug in a y is 1, 5 to the first power is 5, so x is 5. So the other point would be 1, 2, 3, 4, 5, 1. So my original guess wasn't too accurate. It would look like this. It's a lot flatter. But if I take that point, 5, 1, move it left 1, down 3, left 1, 1, 2, 3, now I know that that point right there is my other integer point. So that would be from the origin, 1, 2, 3, 4, and down 2. Now let's talk about domain. How far left does this get? Well, it tries to get to 0, but it can't touch it because that's an asymptote. X can't equal 0. And then how far to the right does it go? Forever. Range goes down forever, goes up forever. So that's all real numbers or that. How about domain on this one? Well, we bumped the asymptote left 1, so that's going to be -1, and then it goes to the right forever. And the same thing with domain range. Goes down forever, goes up forever. All right. All right, got a little recording time left, so let's tackle number 28A, and then we'll call it good for this particular video. So, solve each of the following triangles completely. That means find all missing angles and all missing sides. So as you can see, we got one angle, angle C, which is going to be significant, and we got side A, because that's opposite angle A, and we got side B, because that's opposite angle B. Now, the question is, can we use the law of sine? Well, the answer is no, because we have angle C, so we can use this, but we don't have side C. We got side B, no angle B. We got side A, no angle A, so we can't use this yet. And you can see I've already jumped ahead. We have angle C, so that's going to trigger me to go ahead and try this, and we're going to find side C, because that's what's missing, and everything else is given. So C squared equals, I'm going to go ahead and pause this a second. So as you can see, I put everything that belongs. A is here, squared, B squared, A, B, cosine of C. Just multiplied that all out, ended up getting this, took the square root of both sides. I know C can't be negative, so 14.8 is C. Well, now that I have this angle this side, I can use this portion of law of sine and then just choose whatever I want. So let's go ahead and dig into that. So sine 33 degrees all over 14.8. Make sure your calculator's in degree mode, guys. I didn't mention that. Now I'm going to go ahead and find angle A first. So that's sine of angle A all over side A. And here comes some math. Sine of 33 is 0.545. And I'm going to multiply that by 21. And I get 11.43 equals, and I'm going to multiply this way, 14.8 sine of angle A divided by 14.8 divided by 14.8, and here we go. So divided by 14.8, 0.77. So 0.77 equals sine of angle A. So if we go inverse sine 0.77, that will spit out angle A. So second sine 0.77, 50.35. Let's just call it 50.4. So 50.4 is our angle. And now we know this plus this is 83.4. And if we subtract that from 180, we should be in good business. 83.4, 83.4. 96.6. And we're done with that problem. Here we go. See you in a second.